Hey, it's Coffee Compiler Club here today to talk about compilers and language runtimes and the state of our all personal projects on languages and whatever other things. Being recorded, you'll be on YouTube within a couple hours. Open mic, ask away. I was going to do an AA update because I had somebody asking about it in the Discord, but that can, whatever people want to talk about.
Yeah, why don't you kick it off with AA?
And then I'm going to kick it off with an AA. I put some slides together a while ago. I don't think I have shared them here. They haven't changed in a while because I put them together a while ago, but that's because I've been doing typing things. So is that like readable here?
Yeah, I can read it.
Fine. Yeah, right. Okay, so there's a big, why, whatever. Here's some more design goals. I go read all the design goals, all languages, and they all say ease of use, understanding, concise, fast. So it's like everybody everywhere says that. But I wanted first-class functional closures, first-class functions, the real ones, and static strong typing with type inference. And a well-specified cost model, which you don't typically get out of functional programming languages, and it looks like C without keywords. So those were some design goals.
Functional and C?
Yes, both at the same time. I'll show you in a couple slides down.
Sounds like you're crossing a line there.
I know, but weirdly enough, I can write functional coding and C coding, and you can flip between the two within the same expression
But
freely.
C has first-class functions.
I'm sorry?
C has first-class functions. I don't see what the problem is.
There you go. So very small number of core language features. Like I really try to minimize things, although maybe it's harder to tell at the syntax level, but there's not a whole lot that's syntaxy in there. There's a hard inline guarantee for primitives, and you can ask for it on other things. There's no keywords, which people have talked about plenty. There's no modules at the moment, but I'm going to have modules, but they're going to be effectively a struct with a little syntactic sugar. Oh, and here's Arthur now. See, I'm not paying attention to that one. There's a little syntactic sugar for modules, but they're going to be, just going to be a struct that you've imported from outside your compilation unit and exposed whatever things you're importing. To export, you're going to have the reverse. You're just going to list the things, and that'll turn into a struct from some other compilation unit's point of view. Loops are done with normal everyday functions because it's a functional programming language. So here's some basics. There's a variable x in the first line, x : =3. It's just mutably assigned. A final assignment skips the : equals, just use an equals. There's normal operator precedence. You get auto widening. That's all in there now. Unpacking tuples, I don't have in there, but that's an easy syntactic change. So if get point returns me tuple, you can unpack its parts. You can define new variables in the middle of an expression and use them later in the same expression. So here I have the range is math.squirt of dx squared times dy squared, or plus dy squared, and then dx is defined as the delta from x1 and x0 and so on. So I'm just putting new variables in the middle of an expression. I'm using trinaries instead of if then else, although I have enough flexibility that I could define an if then else with trinaries directly, and it would look like you'd think an if then else would look like. Any non-nil vowel is truthy and nil is false, and empty strings are not nil, so they're truthy. So no JavaScript fails here where weird things are truthy or falsy. Strictly nil is falsy. You can also define variables in two arms of an if, and then they'll be available afterwards if you define it on both arms. You only define on one of the arms, it's used in that arm and that expression, but it's not used afterwards, not useful or not available afterwards. Standard short circuit operators, I might yet demand that ors and ands and ors be properly parenthized every time, as opposed to doing precedence. The second line, x : y : 0, defines x and y 0. Z is x++, and y++ means that x is 0, and it's post incremented to 1. Y never executes. So y remains a 0. So the tuple result is 1, 0, 0. And then truthy tests come as part of the conditional test. So temp is some expression and temp dot is field or is function or whatever. That just means temp's known to be not null. Same as you did in isa. It's available after the test as the sharpened value. The last line, you don't have to put a :0 if you just want a nil to come out of the final result. So some value is pointer, which is not nil. So pointer 1 times dot pointer 2 is not nil. Pointer 1, 2, 3, whatever, and get a value out. I might also at some point add an Elvis operator in there, which is a syntactic small step away from what I've got already.
Do your and ors there in the standard short circuit operators, do they expand into ternaries? Or do you actually have those as primitives?
They're all operators or functions under the hood with hard inline guarantees. The ands and ors make use of a feature I haven't talked about, which is I can flag an operand as lazy, then it gets thunked and passed in as a thunk. So the actual expansion of and there is a function call to the ors, the zeros notion of what and means. So I look up and 0. I get a function. He takes 0 as one argument, and he takes the remaining argument of 1 as a thunk, which he chooses to execute or not. And then you repeat that for that whole sequence is nested inside the or because of precedence.
Yeah.
Which is another.
So can anyone define a function that thunkifies its argument?
Yes.
Oh, cool. So
you can make a ternary operator, or under the hood, the ternary. Well, the and the ors actually go to a primitive IR internally, the same as the question mark : goes to the same primitive IR sequence internally. So that it's two directions or two paths into the same underlying IR that I type. So structs are everything can be anonymous here in AA. Functions and structs. I'll come to functions in a minute here. So here's I've declared a variable called point or endpoint, named point, has a name, has an X and Y. And then the struct operator is the ampersand. I think most people here have seen that. And then it behaves like a struct. So I can say endpoint.name and pull a field out and print it. And I can set X and Y on it pretty directly because I haven't done any privacy things. And we may argue private and public variation thematically, who's the default later. Right now, if you don't say anything else, it's a public mutable field. So X and Y are public mutable fields. Name got finally assigned, so it's a public final field. Tuples are like structs, and you can access them with an index as like field name. So I have a tuple of 1, ABC, and endpoint, and tuple.1 pulls out the ABC, and endpoint is also can be indexed by 0, 1, 2. So I can pull out endpoint.0 and get the cliff field out. Arrays are going to be range checked. There'll be some sort of storage assignment, which I haven't totally settled on the syntax for that. If you like the first line does an untyped array, but it's all strongly typed. So it's going to be type inferred, and you get the default storage class for the default inferred type. So if array is defined is typed as a array of doubles, it'll be 8 bytes per. Read, write, and length are all operators. So E is array sub index, just reads the value out, and that's the square bracket operators are. Well, the operators. So I have a sequence of operators in the bottom there, where the green is the place where things happen. So you put an expression for the underbar for create, that makes an array. And you put one before and one in the middle of the index operator, that's a get. And the put takes one on the other side and so on.
Looks like the pound sign was meant to be black, not green. Is that correct?
Yeah, other than it's syntax, so I should probably make it black here. I have to go sort out how to do that. You're correct. And that's confusing. So it's not line color. What is maybe it is line color. It's font color. All right, I'll deal with it later.
How does create overload works? Like I can understand that for get, put, and size, you have the actual like receiver for the operation, but for create, looks like you only have the parameter which is interpreted as size. Do you overload by the type of this parameter?
It's type inference. So if there are no other uses of array and it's dead, then I don't care what its type is. But if an array has other uses, then type inference will tell me what's an array of what. You could put a type on it. All things, I haven't talked much about type annotation. You can add type annotation anywhere. You could add a type annotation that says, I want my array to be an array of ints or array of persons. If you don't annotate, I'll go infer it based on the other uses.
Okay, got it.
Okay. And in fact, I'm showing things without type annotations, but I actually am a firm believer in type annotations. They're really helpful documentation. There's sometimes you just don't want to care and you just want to write code and move on and get the types figured out later. So here's functions. All functions are anonymous. They are open curly, and then the guts and close curly, and then in the start, there's a list of variables and an arrow and then expressions. And you can put your type annotations anywhere you like, including on the variable on the left-hand side. Distance is, X and Y, and it does the whole distance calculation. But you don't have to, or you can annotate on the arguments, or both, or neither, or on the function result, or anything else. So then,
so if functions are all anonymous and you get a stack trace, like, is it totally unintelligible?
Well, I'll give you line numbers.
Just line numbers, so that you won't have function names.
No, right. So in the case of dist equals a function as a final assignment, I will, under the hood for debugging purposes, associate dist to the name with that guy. Now you can't use dist as a name. Dist as a variable you can use anywhere, but dist as name you can't use, but the debug info will track that as a helpful thing. But if dist is variably assigned to any number of different functions, and then I call dist, and in one of those functions I throw, that function might have been assigned another name at some other context and has nothing to do with dist. Right? The mapping from functions to names is no requirement to have an anonymous function. Same as you get in Java right now. You get a lambda argument, you pass a lambda argument in, you throw an exception in the middle of a lambda argument evaluation, you get a bogus stack frame for the lambda evaluator that says he's lambda $n, or whatever it is that Java gives you for the debug info for a lambda. That's the kind of thing you'll get. So it's not like it's nothing, but you can get a line number, know where it is, but you won't have a name. Okay.
Yeah.
So the C-style function call for Levo, distance of xy, says I call distance with 2 arguments on x and y. Looks like a C-style call. But I can also do a 1-argument adjacency call where I just take a function and an argument next to each other, and I'll make a 1-argument call. So secretly under the hood, these two syntaxes are entirely compatible with each other. And I do them both simultaneously, ambiguously, and you can't tell them apart. So actually dist is passed a tuple of x and y, who he unpacks as syntactic sugar for the x and y fields. But dist is a all functions take exactly and only 1 argument. It's often a tuple who will often have your arguments aligned, and he'll unpack for you. Then there's some typing annotations if you want to do currying, and if you want to do, different naming rules and explode if I don't have the right argument counts and the like. The default situation is you want the correct argument counts and types in your tuple, and so you will get an error there, but you can ask for a varargs function, and he'll just take a tuple and you'll unpack it yourself and do what you're going to do with it. So I claim these 2 function call styles are entirely compatible, and I don't distinguish between them. All right. The next line down, short form for no arguments. If you have no arguments to a function, you can skip the arrow. So just putting curly braces around some code dunks it straight up without anything else. If you wanted to make some code not executable because you're trying to debug something else and you don't want to deal with this piece of code right now. You just thunk it and then deal with it later. And then operators have the magic underscores. I think we've talked about this before. And they get, the parser knows they're an operator and we'll call them infix style. But when he unpacks it, it's syntactic sugar for a function call that consists of a call to a thing called under plus under, which is a field and then some struct that I load out and I get a function out of it. So functions can be recursive.
Can I create my own operators with
Yeah.
that syntax? Can I just say underscore less than, greater than, less than, greater than, some like, if I'm just thinking about Haskell with these crazy operators they have, and then just put underscores on the ends, and I've got like my own.
Yeah, the underscores tell me where the operands go.
Yeah.
So if they're surrounding the token in the middle, it's a Boolean, it's a binary operator.
So I could do like, Haskell has like underscore, less than, equal, greater than, underscore, which would be some sort of monad operation. Can you like define that in AA? Like,
Yeah, I'll actually do some Google Docs. Hang on. Yes, how do I change my share? Okay, stop. Boom, share. Google Docs. Start again. What are we doing here? Code block. Okay, so what was your question now?
so I'm imagining that I want to define my own custom operator, which is
Gotcha.
Takes two arguments, so it's something greater than, less than, equal, greater than something else. I believe that that's a Haskell operator, although I don't recall what it does. I'm going to open up the document and write it.
So here I've written a matrix where I've given operator assigned a value and then I use it. Just like whatever, yes. So, all right, so operators have some rules on them that are more than I've just mentioned. They have to be inside of a struct. I am going to do a struct lookup. The left-hand side of the binary operator will be your first argument into the operator. And you don't get any say on that. It just has to be that way. And I haven't decided what the syntax, but I'm going to use dot like it's a this pointer.
Mm-hmm.
So you have some other matrix is da da da. You have some matrix spaceship operator is equal to a function that does something. We'll use the word this instead of dot, make life easier. You're stuck with the one operator. Now no, this will fail because you have exactly two operands. Yes. So your this operator will be A and B will be the other guy. Yeah, there you go. And now do whatever you're going to do for your functions with this and B. Yes. And because it's baked in as this operator, it means you get the contents of other matrix as in your namespace directly. So you don't have to call out the local variables that you've got. Like other matrix has a number dimensions field somewhere. You've said, here, I'll add it to mine. Oh, here's Aaron. Dim, I'm typed as an int. I haven't filled out what my dimensions are here, but I have a dimension field. That means that inside the body of my code here, I can just use dim directly without saying this.dim.
Yeah.
Right, and you could call dot product and just dot product some externally defined function. You found dot product elsewhere in the universe. So
and then are you limited to which characters? Could I like do like that, and then I'd have like m dot. This is maybe
no. Yeah, you can't use alpha characters in operators. I have to go look at my syntax. I have to be able to distinguish at parse time without any notion of typing what's an
Mhm.
operator and what's not. So operators have limitations on their syntax that distinguishes them from general identifiers in all situations.
I
It
see.
won't be an operator if there is a
Are you
typo.
using a fixed set of ASCII, or are you pulling in everything that the Unicode database considers to be punctuation?
I am currently using a fixed set of ASCII, but I could totally, it's just a list. I could just add things to the list and Unicode your life to your heart's content. But you can do that.
It's just a long list.
Yeah, exactly. But I don't care how big the list is in a parser. Fuck, it's just an array lookup. I probe my table and you hit a 1 or 2 or false and it says, oh, you're a good character, or you're not. Nah, fine. Yeah, so
can I do like this and then have a you know,
put your summation operator. Now you don't get to say the word operator. You have to put the operator in another class, the other matrix class.
Right.
In your other matrix class, add a new guy. Yeah, right there. But yes, that would work.
that would work.
That would work. If you want to make a 3-element operator, you're more limited on what your operator characters in between the set of 3. You must have one of the several matching, and you have to have the alternate matching elsewhere. So this would work as an operator as a 3. So here we go. This would be this index value arrow. Do what you're going to do.
What if I do something as a grouping operator, but I also try to use one of the grouping endpoints as like a unary operator?
There is you're not allowed to do grouping operators that don't group. So grouping operators are used on 2 or 3 things. One, 2, or 3, where it's in the middle and the 1. They're mid-fix or whatever you can call it. And unary operators cannot use a grouping operator syntax, at least not in the first 2 characters. The first character, there's a distinguishing first character that lets you do something. I'd have to look what the rules are. So you could do %and as an operator. You could do and % as a postfix, like pound. This is my standard for length. But I could do that postfix as well, and I don't care what it does. But I couldn't do square bracket like this. That's a parse error, not a type error, because the parser doesn't know. He thinks it's a grouping operator. He demands the closing grouping operator.
So it's actually that character that's considered a grouping character.
Yes.
Okay.
And having found a grouping character, I look for a sequence of characters afterwards. Somewhere in the world, I want to see some sequence and then the closed group to enforce it. So I am enforcing some rules on what your operators look like to make it hard for you to write yourself into a corner where you have something that can't be read by anybody on the planet.
Interesting. So, but it seems like you could define yourself like a pretty close subset of, like a pretty large subset of APL using AA.
Yes. Now, in the one you have multiply and, I'll give you a parse error because the multiply has already been defined as an under multiply under with no extra characters behind it, and you are not uniquely defined as a new operator. So there is a list of known operators, and as you add operators, they'll append onto the list, and you can't have operators whose prefixes are not unique. They must be prefix unique. You can add extra shit afterwards, and I don't care, but because the parser doesn't know shit from Shinola, right? He doesn't know if you're intending to have an ampersand under as a postfix only operator as well, separate from the multiply operator. So the parser says, I see under, I see a multiply. Well, you defined it. Yeah, you see an under, you see a multiply, I see an under. I go check, is that prefix unique? Me add the ampersand, is that prefix unique? Me add the final underscore, is that prefix unique? They're all prefix unique. Good, you know, no ambiguity, I'm done. Oh no, under multiply under is not prefix unique. I found one. Sorry. So he won't let you do that particular one.
Oh,
So that's the limitations of the parser, making him not ambiguous. Somebody asked a question about shift right assignment operators. Assignment operators can be written in. I'll do some, and including the one you just wrote there. And that's a this style thing like this. Let me sure I believe it's correct. And it gets a this and a shift, and I do what I'm going to do with it. So the left-hand side is this operator is always the target of an assignment that's going to modify something. And that's the only guy that gets an L value. Everyone else gets R values.
But you're not putting in arbitrary rules like if there's an equal in there at all, it better return a Boolean. Those are comparators.
No, but if there's an equal in there at all, I don't know if I demand a following underscore or not. I don't think I do. And they don't have to return a Booleans and be comparators or anything like that now. You can have comparator operators that do weird ass things, and I don't care. And I see people are making up things for me.
Oh, yeah, no. So like, I'm just tired of this competition at this point. I'm like,
the whole point of the competition.
I don't know whether it's, whether there's actually $100,
Oh, totally. The point of the competition is get you off your ass and writing some code. Has no other purpose in life.
So
I want to see some Strauss-Cat written.
Yeah, so I figured, writing it down in the and publicly announcing it, so that we can be publicly shamed if we.
Yeah, I'll do a little public shaming. Yeah.
So,
Sorry. Meanwhile, if Levo comes up with his auto memory management, I'll throw $100 on that. No problem. I'm all excited for that one.
I didn't actually take the bet. You guys were talking about it, and I'm like, yeah,
Oh, no.
Sounds like I can win.
The bet stands.
This isn't a bet, it's a bounty.
Yeah, if you win, I'll send you $100 unless you totally refuse to accept the $100 from me. I'll just send you.
I'd rather have 4,000 lines of code written in my language.
I'm worth more than 4,000 lines for $100.
You're valuing that code at 2.5 cents a line.
Yeah, but it's code that he has to write in some language anyway. It might as well just be mine.
Yeah, I could do the degree op there. I had no problem with that one. All right.
So,
are we done beating on operators?
I am.
For
I had a
now.
mini update, and I can ask you about your truthy thing that you mentioned earlier.
Yeah. That's a good time.
So if you have 2 as like a variable, it's going to be true.
2 is a value, not a variable.
Okay, if you put 2 into a variable and then
Yes.
you do an if statement on that, it's going to let you do that. It's going to consider it as true.
And be
Does anyone else think it's a bad idea? Because I was thinking about that, and I wasn't sure if I want to force pools or not.
I have done C code forever and a day. I never had any bugs come out of using 2 as a bool. I routinely have to say pointer equals null. It's a complete waste of time because I just want to test the fucking pointer for null, then use the not null value. And so I think Java got it wrong by forcing the null versus not null on pointer tests specifically. That one's just verbosity for no gain, at least in my opinion.
Yeah, I agree with that one. Yeah, so what I end up implementing the other day was I have so instead of enums, I have something called bit flags, and if you do variable dot then one of the flags is read only, that's going to be considered as both a value and something that you can use with an if statement. So if you assign it to an integer, it says 2, but if you put it into a bool or in an if statement, it's just true. So I have that, and I like that, but I'm not 100% sure if I want to just implicitly cast ints as bools. Like I'm not sure. Like I'm not saying it's a bad idea. I'm just not sure yet.
Okay.
I had no issues in C, but I'm used to C.
Zig did a thing with error codes where they grouped them into enums, could stack them together, and there was a known special enum, which is effectively the 0, which was no error, and all the other enums were not 0, and also they could be lumped together. It was a useful looking thing for doing Linux OS style error code management in complicated situations. I thought it was kind of fun. Is that what you just said sounded a little bit like that?
Yeah, a little bit. Yeah.
All right, so here's functions. I'm going to go a little deeper here. So here's a recursive function for factorial. I typed it as int to int. In fact, right now on my operating table, it will be int or float. I don't care. Any function which takes an argument x, which has a multiply operator and a subtract operator and a less than or equal operator. And if you have all three of those operators, that's fine. And that's the type of the factorial function. It takes an argument, has a plus, a minus, and a less than or equal. So it's a much more generous acceptance of what a factorial function is than just
Does it also have to have a two bool for the question mark?
No. You got that out of the less than equal. X less than equal 1. So that gave you a bool already.
Oh, not x equals 0, but less than or equal to 1.
It has to have a less than or equal, which takes an integer
Right.
second argument. So your type of fact is a struct x, takes a struct x, and returns a struct x.
Yeah, I see.
Okay, fine.
It's just that the less than or equal must return a bool, then you're happy.
Yes, it turns out that it will return something that's fed into question mark colon, and question mark colon is like really generous. So the implied effect is whatever x less than or equal to 1 is anything, because question mark colon will take anything.
Yeah, I know you were talking about earlier doing things like for any structure, if the bit pattern is zeros, then that's
Yeah,
false.
I'm back and forth on that one. It might yet happen. It's not a done deal. I still have to get myself to where I believe I get all the typing I do want, and then all the bonus extra effects will come or go if they fit or not. I've been spending the last year cutting out cool things that look like I could do that I probably need to, second system effect myself and quit adding cool things and start chopping shit out. All right, I do have the side effect things for functions capturing. I think that one's fairly well sorted out. And here I just said, count is some variable, some scoping level. I make a function which increments count. It takes no arguments, increments count. Okay, captures the external variable via side effect, via reference, and increments it, which has a bunch of effects, including count has to be stored in a struct somewhere, and then it can be incremented. So there's some storage set aside for count. And its lifetime is kept as to the lifetime of whatever the increment is. And I know that I can tell you that it's no longer stackable, and that you can ask for it to throw an error if you want to be stackable, and it's not. But if you're not being stackable, then your stack frame just got moved into the heap to hold count. I've just captured you and put you in the heap. So then I make a make counters guy, who's a no arg function. He declares a variable count, which will default to be mutably 0. He returns a tuple of two functions. One just returns count. The second function returns an increments count. So then I call my make counters, and I break out the two functions into get the counter A and increment the counter A, and get the counter B and increment the counter B. And then I call increment A and increment B just to show they're all different. And then I scale them so I can tell they're different. And I get an answer out that says I have two different counters here. So is that legible enough?
Glad there's a garbage collector for that logic.
It just needs to have storage management of the lifetime for where that goes. So what I'm going to come around to is
right. The minute you return that thing,
yes,
now become the lifetime of the caller.
Yeah, right. So there's either going to be implicitly scoped region memory, and you're going to have to say I want scoped memory for this, or I'm going to have a garbage collector. And if you say I don't want a garbage collector, then you'll get a type error that says you have to what part of the compilation here would be what is your runtime machine you're targeting. If your targeting machine has garbage collection, done deal. If you're targeting a machine that does not have garbage collection, then now you have to do storage management. And you'll get told that as part of the typing errors. Hey, you got to use storage here, and I'll give you some default storage management solution here in this case, which will probably be stacked somewhere.
I have a question. I have a question about mutually recursive functions. Can I have like function A calls function B, which calls function A?
Yeah.
How would you define that? Because it seems like you just wouldn't have one or the other in scope.
Well, you don't. and then I get a forward reference, which I resolve at parse time. So let me go back to the Google Docs, and we'll do is even, is odd as the canonical stupid easy example. Is that the correct Google Docs?
Later on, I can ask about make counts because that's hurting my head.
Yeah, okay, I'll come back around to that one.
Yeah.
Here's another one. Okay, let's do, what do we got here? Is even, is odd. Yeah, so what do we do here? Is even is a function which says if x is even, so you know, and 1 is 0, then this will return true, and otherwise it's going to call is odd on x minus 1. And is odd is a function which takes x, which is x, and on the low bit is equal to 1. So I'll make this equal to 0, so it's a little easier to read. And if that's true, then it's true, and otherwise it's is even of x minus 1. And I misspelled here, so I'll go add a little space there. Okay, there you go. There's two mutually recursive functions. And maybe I didn't get them right or wrong, I don't care. But when I come to the parsing of, so when the parser comes along, he says is even is equal to, there's an assignment, we put is even off to the side, it's not defined yet. I go x, function, body, arrow, blah, blah, expression is odd. Oh, I don't know what is odd is. I'm going to assume it's a forward reference to a function. And then I complete a function call on it using x minus 1. I end up and I close the curly. I say I now have a definition for is even, so is even is defined. Then I come along and say is odd is equal to. Aha. Okay. So I'm going to bind that to the forward reference I already have, and then I carry on function definition, blah, 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 blah. Then I come to is even, I've already defined, so I get a function definition. So it's just not on the parser with the forward reference. So it's a one and a half.
Even though is even and is odd are immutable assignments.
Yes.
I guess.
Yes.
Okay.
The semantics are all as if.
So does this also mean that if you define is even and you don't define is odd, it would work as long as you called it with even values?
The compiler would have to prove that you only call it with even values. Otherwise you get a typing error that is odd is not defined.
Yeah, but if I gave it a constant even to try it out, I could actually do that.
So I didn't talk yet about dead code, but dead code doesn't have to type.
Yeah.
What would happen if I... So in theory, I could return this thing, even though it has an unresolved forward reference in it?
Yes. And now you have a module that has an unresolved forward reference that has to be resolved in some other module. So that has to actually come from another module scope, or it won't let you return it. You'll do a clear type error. I have to prove is odd in the local compilation unit. Is odd is either dead or it's defined. One of the two. Now the definition can be I pulled it from some other module, but that's just a field lookup in another module struct, which says you had to pass in a module that has an is odd.
Right. That's why I was thinking of the return. If I close this scope before I've dealt with all of my unresolved references.
Yeah, it either has to be dead or
then
resolved.
That's an error.
That's an error. That's correct. Yeah.
Okay. So I can't return is even here.
You cannot return is even right there. That is correct. Because is odd is not defined in whatever scope you've assumed you have.
But I could totally return is even here.
Yeah.
Cool.
Okay. Is the hat
hat is return?
It's return.
Oh, yeah, okay. I'm coming around to that. I believe I'm coming around to that, but hat is return. Yeah. Okay. I have some examples using hat and funny returns in the middle of functions, like find over an array. It finds an element in the middle. He exits the loop early with hat as a return. I'll come to that. I'm going to go back to help Levo get his head unhurting.
I kind of expected you to do the arrow pointing in the other direction because you have arrows for your functions.
You know, their syntax could be argued left and right. I'm not closed on everything here.
But hat's not terrible.
Hat's not terrible. That was my opinion. Given the constraint of single character or keyword replacements, hat's not terrible. All right, Levo, what's hurting your head about make count?
Okay, so in the curly braces.
There are many curly braces. Which curly braces?
In the line make count.
Yeah, the first set of curly braces.
So
I'll highlight it.
I'm
this.
assuming that it knows it's an integer because there's a plus on it, but I don't understand how it knows that the first part of the tuple is both an integer and that both a function that you have to like a getter and a declaration, because I'm not sure where
Okay.
the count is declared.
That's the declaration right there. I just highlighted it.
So it's both a declaration and the return function or a getter.
No, it's not the return. It's a definition. So if you name a new variable that's not in scope, and you name it with if it's not in scope anywhere, then it's not a read. It's defined right there as a mutable nil, mutable 0. This is shortcut for count : equals 0. If count is in scope, then you just read it. And it's now for rest of the function, same as Python, rest of the function, you're referring to the outer scope count variable, wherever that was in scope. If it's not in any scope, you've defined it here. If you're worried about scope because you've got a lot of variables in front of makecount, you don't want to get one by accident, you need to define it properly.
I think I
Does it know
understand
that
the
was
second part.
implicit : equals and not just implicit equals?
It's : equals because it's mutable. Yeah. Yes. If I did this, I get a type error because I'm incrementing count. The count's been finally assigned to nil. I can't increment it.
Also, it's kind of pointless to have an immutable 0.
Yeah, right, exactly. Yeah, immutable 0 stick, right. I might as well call it 0 and walk away, whatever, fine. I mean, I can call it nil as a fun word nil instead of the 0 token. I could say nil is equal to 0, and totally that would just work.
So are you saying that it actually acts as if when you don't have the : equals 0, you just have the semicolon alone, it acts as if you've assigned it to 0 immutably? I'm just wondering because what if I, have this count, or like I have something that I defined, but I actually wanted to set it to be a struct.
Okay, so I switched slides.
Yeah.
Named point is a struct containing name equals quote, cliff quote, x semicolon, y semicolon. What are the x and y here? Why are they defs and not reads?
Yeah, well, like, maybe what if you had one called address, and then it's like, not like a pointer address, it's like a home address structure. For some reason you haven't signed it, but it gets this sort of default assignment to 0. Is that going to cause you type errors if you try and assign it to some structure? It's like, oh wait, that's not an int.
0 is special. It's from my lattice typing. 0 is the null pointer and the integer 0 and the floating 0 all simultaneously, all ambiguously, all well typed.
Right, okay.
So same as Java, I assign a null into a pointer. Here I have 0 is the token, meaning null if your type is a pointer, and integer 0 if your type is an int.
Okay. Right, I forgot.
If I have some complex object, there's no like default constructor that is going to call the default constructor of your class or whatever.
As soon as you define a struct, you get a constructor for the class. As a type, if you write a struct in line, like I did endpoint here, there's no constructor other than what you put in for the arguments. You get the default effects for X and Y, name you define directly. If you type it and typing's coming up, you get a default constructor, and then you can add more constructors that do other things. And the default constructor will put nulls in for all fields, basically, except fields that you've defined elsewhere, which we'll get to when we get to. Okay, back to make count. Are you okay with this now, Levo, or more needs to be said here? Okay, Levo's quiet. Either his phone died. Oh, I got chat now. Let me go check and make sure Levo's not dying. Okay, Derek's out. Fine. Fine. Okay, I'm going to claim victory for Levo, but I don't have a confirmation audibly. And go on here.
Okay. So in the doc, my question was, if I have this thing, will it expand?
So your question is, when do I get a constructor? And let me get to constructors when I get to constructors.
Sounds
okay?
good.
Okay. So they'll be along in a minute. So I have no special syntax for loops at the moment, and I can get really close to decent syntax for loops without having any special syntax. So here's the definition of a while loop as a language keyword you might want to use, but it's just normal syntax. It's also bad to read, so don't read it. But you can read it if you want. It does sort of obvious things if you're a functional programmer. So then I'm going to go use it in a exploration here of an array. So somewhere in the world, I've made an array. I've got an index 0, and I do a predicate test, which is I++ is less than the length of the array. And that loops until I run out the length of the array, until this test fails. And then I take the contents of the array and I assign them to I squared. I'm computing an array of squares for whatever reason, because it fits on a slide, right? So I know my array, for Arthur's sake, I know my array's type is an int, because I'm taking ints and multiplying them and storing them in. And I have a body of the loop in curlies, and I have the predicates in curlies, and I have two functions. So while takes two functions via an adjacency call. So while as a defined here in my use case has to be a function with an adjacency call taking an argument. And if you look up at the while is equal to line above, you just see it's defined as a function that takes a predicate as a first argument. That predicate is a function itself. That returns me a new function, which takes yet another function. So the execution of the first while with the first body gives me a new function, which is now the body function passed in. And then I go down the line of what I do with the thing. And I ask the predicate if I'm going to live or die. And if I'm going to live, I call body. And I don't care what body returns me. I just call a while loop and rerun the predicate again. So given tail recursion optimization, this turns into an actual loop that does exactly what you expect it to do. I don't know if I'm going to do all my for loops like this, but I can go pretty far down this path. There are a few things I don't like about it, and then a lot of things I do. So it's an open question.
And I is in scope for body.
And I is in scope because it's in scope, because I is defined ahead of in an outermost scope, and so it's readable in the body. Yeah. This goes to the heart of the problem I have with syntax on for loops, which I'll come to in a slide.
Yeah, you can't
here.
put the I in the while.
Exactly. And that's what I don't like. So let's go look again another example. So here's a for loop, which is going to run until the body is not nil and return it, or the predicate is nil or false and exit with a nil. So you either exit with a not nil and whatever it is you got as a not nil, or you exit with a nil. And the exit with a nil means I didn't find. And if I found something, I exit with the thing. So find is a 2-element function, takes an array and an E, and he's going to go look up the element. And in the middle here, I have a for loop where I say run to the length of the array, right? But I've set I to 0, but I can't put the I inside the for loop. Exactly the problem I don't like for Aaron. That's exactly the bug. If I get a hit, I found that thing. Then I return something that's guaranteed not nil. Oh, that's kind of awkward. But I return a guaranteed not nil. So I have to subtract one of my index when I come out, so that if I fail out the end, I'm actually returning an index -1. And if I fail off the end here, I will have maxed out, and index will have been left at what it was at the initial. We left at the nil that got returned, and I'll return a -1. I'll return a -1 if you don't find, and I'll return an index from 0 to length of the array if you do find. So I write this kind of code in C or Java all the time, except it's a little more explicit. So this one is awkward, and I don't terribly like it.
Yeah, the +1 feels like you want to be able to return a int or null, but
I want to I can write code that's more bulky and return a -1 exactly on an exit. That's the thing I didn't do. So I could expand this code out a little more, and it would say in the middle, I'll return I on a hit. So it would do a question mark, return I. So I could do this. Maybe I could just do. I don't know, why can't I do this? I'm returning I. If I fall off the bottom, I have to do double returns here. That's what's going on. And if I fall off the bottom, then I'm going to return a -1. So that's probably actually a better way to write that. I didn't think about the double return. I'd have to make sure double returns work. So return twice. But
What-
that's
Double
awkward.
What does
return means
mean?
return not to my caller, but my caller's caller.
Yeah, right, which is awkward. That one I have to think about if I can make that work. Because I return once to gets out of the body. I return a second time it gets out of the for loop. The for function.
The second
itself.
time returns to the find to find the
Yeah,
scope
returns
of
to
the
the find.
find.
Yeah,
Yeah. So
it's
I
not
think it
obvious to me
works.
whether that causes spooky action at a distance.
Exactly. That's what I'm
Double-
worried about.
Double returns does it means jumps to stack frames.
Yeah, 2 stack frames up. Like Aaron says, it kind of starts to smell like spooky action at a distance.
Right,
What-
because
what about
anytime I
triple
call any
returns?
function, that might be a return.
Yeah,
What
if I
about
call
triple
function might
returns?
return past me and never go. So I don't like this one right now.
Which is true if you have exceptions anyway.
It is.
Closure solves sort of deals with this in a different way. It has an reduced object. So you wrap the return, the thing you're returning in reduced. And so like certain functions like reduce and
That's
reducers like check for, they like specifically watch for reduced.
And then they peel it.
And then they like, yeah, they exit. So it's kind of like a break, I guess. But
that
Okay.
sounds like tail recursive function. If you call the dx at the bottom of the find, it should return. And
Yeah,
you don't need a double return.
my instinct is I just want to trap. I want to have the double return, but have some way to say, hey, I'm doing this function call, but like wrap it in a try or something and be like,
So-
no, you can't go past me.
In the case of
Stop.
Java and C, you would write a find using a return in the middle of the loop. That return would exit the loops structure and the finds function as well. It does a double return.
If you make the IDX accept an array for its argument, because you reference it because it's defined inside the outer scope of the find function, if you make it the IDX accepts an array, and at the bottom you call it with the argument of the find, which is an array, it should return right there.
Yeah, I could restructure the
That's-
find call. But what I want to do is write something that smells like a for loop that a C programmer would be comfortable with.
actually getting
Yeah.
kind of close to like to call CC,
Yes.
where you're calling with continuation, and
Yeah.
you like with call CC, it at least lets you define that outer scope to say where you want to continue when you call
Yeah.
the thing.
I do have enough typing info and enough IR infrastructure to do call CC, and I'm not sorted out both either syntax or if I actually want to implement that, but I could go to call CC directly. And that might be how this gets resolved in a way that's sensible to read as a C programmer and execute, have a mental model of the execution as well. So the other one that I just said there was that Java has this magic keyword return that returns out of all nested internal function scopes, all nested internal scopes to the layered return point, which is the function body name. So in the land of Java or C, I name my functions. Those name points are special in the sense that the return keyword goes to them, goes out of that scope. Here in the land of anonymous functions, I can't do that directly. I go out to whatever scopes. I've got scopes everywhere. I've got function scopes everywhere here. Hey, Cameron. And because I have function scopes everywhere, I don't have a return keyword that jumps to a particular name scope. But I could, I could do the double hat as a version that says go out to some other function body, not the innermost, but the next, however many, I don't know, you break 2 and break 3 and all those things in Java, they have the evil things. All right, I want to go on, leave this as a known, it's not right yet. Oh, here's the version where I just do the, what was this one doing here? Oh, I see. More work in progress. This is just evaluating the for loop and returning -1 on it. Exactly the same problem as before. I just skipped some syntax for having an index assignment and subtracting 1. I can just, for is just an expression. So it returns a value as an expression. Because of an expression, I can keep doing math on the expression. So I subtract 1 as the expression. That was more of the same, the same problem I had before. both I is defined outside. The
You don't
for
have
loop-
there's no difference in AA between -1 and -1, right?
That's correct.
Yeah. Some languages seem to make that distinction.
There is a difference. No, here it's going to be a binary operator. If I do a -1 bear, then I'll make an unary operator minus and apply it to a 1. And that, of course, all completely inlines and a hard guaranteed inline and gives you a -1 back.
Yeah.
But semantically, it's as if I called the unary minus. Here it's a binary op, not a unary op. So you'll get an actual binary -1. All right, type annotations. You put a colon in a type, you can put them pretty much anywhere. So here I got an x colon int 3, a colon int, and then that's defined for 3. Here I make this expression type as a float. Here I type my arguments for a distance function. Here I put the function type on the variable twice, which just does x plus x, and I put some ints in some funny places because I can. And Matt's telling me that function, the call CC has some issues. Put that in the Google Docs as well, please, Matt. I can name types. That's where I put an equals for an assignment, but then there's a type on the right-hand side. So the colon is after the assignment, not before it. And then I can do things like naming meters and yards and claim you can't do one or the other, whatever. There's a numerical typing thing I've only half thought through that could happen here, but I can just name types. So I think more name types are coming up. Yeah, here's another name. Here's the one with constructors now. Point 2 is finally assigned a type. The type is a struct. The struct has 2 fields in it that are themselves typed. And I'll probably change the syntax on this again in the future. In fact, I probably should change it right now. Oh, I have changed it already. So we'll get to this in a second here. So this is, you get a default constructor that takes the floats in order for the fields. And then you can run down the line here and say dist now takes a point 2, which it does p.x and p.y things to compute distance. And then I've defined a point 2, so I can call distance with a point 2, and it's type correct. But I can't call distance with an anonymous struct with an x and a y float fields, because because distance is declared as a function which takes a point 2. So that's anonymous structs are totally fine if I didn't put a type on it, as long as you had an x and y field. I did put a type on it. Now you have to have a point 2. Point 3
So I
is
get a free constructor for an ordered list of the fields. Do I also get the free constructor for an anonymous struct?
Anonymous structs are defined on the spot, so you don't get a constructor.
But I could imagine wanting to say point 2 and then passing in x equals y equals.
Yeah, we should go look at the syntax here. So the anonymous struct for like the name struct I did much earlier with Cliff and x and y, it doesn't get a constructor because there's no place to even hang the constructor. It got constructed. It was a value object, not a type. It got constructed. You're done constructing. Okay. Points then are 2 things. 2 names get defined here when you define point 2. A type name and a value name. The value name is a function, which is the constructor function. The type name is only available in the type's namespace. So if I use point 2 in a type context, it's the type. And if I use it in a value context, it's the constructor. Okay, so point 3 says I'm assigned a type, which is point 2 now in the type context, extended by a z field. So that just adds a z field. And then I get the constructor, the default constructor. There'll be 2 of them. You'll get one that takes a point 2 and a z field, and one that takes an exploded point 2. And I might change how that works as well. That's another open question. Is that no one's jumping up and down on that one yet?
Makes me happy.
Makes you happy. Okay, so here's nominative versus structural typing. So in the case of distance 0, he takes a struct for P, which has an X and Y, and he does things with it. That's entirely inferable from the context. So that's optional as a type annotation. Has no semantic meaning. Whereas dist1 requires a 0.2. And if you don't pass me in a 0.2, you'll get a type error. So now I'm going to use distance 0 and distance 1 in context here. So distance 0, I handed an anonymous struct. He's okay with that. He'll just do the math and run the function. And distance 1 will complain because that same anonymous structure is not a 0.2. And I can pass 0.2 objects to both distance 0 and distance 1, okay, because in the case of distance 0, that thing has an X and Y field, and that's all I need. In the case of distance 1, I need the 0.2, but I got a 0.2, so it's okay.
But if I add the colon annotation where you say dist1, then it will be happy again.
If I put the colon annotation where?
You have this line dist1 equals literal struct.
Dist1 equals this one. This
Yeah.
one.
If at the end of that I type a colon 0.2.
No, because then you're attempting to declare this thing casted as a 0.2. It's not. You have to call the constructor, which will take those arguments. But you cannot, and I've debated letting you pass in an anonymous struct that's laid out exactly the same or not. What are the overloaded possibilities for the constructor that you get for free? One of them is exploded fields. I think currently I actually do take one of them as a struct that's laid out identically as an anonymous struct. So instead of saying, you said, I'm going to cast it or something like this.
Yeah, I've just asserted it's a 0.2.
Yeah, it's not a 0.2, it's an anonymous struct. So that's a type error. I can run the constructor though. And now I have a 0.2, but I just constructed one and passed it in. That's okay. Turns out
Okay.
I'll make the 0.2 constructor call with a single extra argument by doing that as well. And that'll just call a constructor 0.2 with this struct that happens to be identically laid out like a 0.2. I'll let you declare, make a new 0.2, make a new 0.2 object. So constructor will make a new object, it'll burn some memory.
It sounds like you're calling the 0.2 construction with anonymous structure.
Yeah, I'm calling the 0.2 constructor. So 0.2 as a constructor.
Okay. That's akin to for the same point. Can you call it with the tuple, not a structure, with the tuple with the same type of
No, that would be how many constructors I want to define for 0.2 that accept overload. So this. Actually, this one works the other way. Yes, this one works because it's syntactic expansion. It's exactly the same as this. So you're correct. This one works.
Okay.
And it's effectively the same as saying new 0.2 in Java with the exploded fields. So yeah.
Okay, fine.
Okay. Yeah, here's a linked list, and I'm still debating the syntax for adding type variables, but this linked list is defined to be a type which has a struct, which is a next field, which takes a linked list question mark, so that's a nullable linked list, or a value field which is totally untyped. There's a list of anythings. And a linked list of A says that it's a type which has a struct, which has a next, which takes a linked list of A's again, or nil, and the value must be an A. Mutably assigned an A.
Can you drop the value A and make it any type?
That's the first guy, right? This is.
How do you distinguish next is either nil or a linked list of A versus next is a linked list where A is optional in the linked list?
I'm sorry. Oh, the type.
Yeah.
This is the syntax question for how do I do. See, it's not good to see here. When the parser sees linked list equals, there are no type parameters on it, so they're none allowed in the body, and value is untyped, so it's a free anything you want.
Yeah.
This one says I did a linked list, I did an A. That's unusual syntax already. I found an equals, I found a type. This must be a type variable. I don't necessarily like this syntax 100%. I haven't settled on it.
Yeah. I'm just thinking that like you couldn't, maybe this is where I'm mistaken. Could you also have a linked list with the type a question mark? Or you'd have to have a different name, I guess.
Right, and this is the reason that I don't like the syntax, because the binding of the question mark is ambiguous.
Yeah.
Yeah, that says that my A's themselves can be have another type on them, which I don't currently have a good notion for. But you could say A is typed as a B question mark. So when I use A, I'm really referring to a B, which is another free variable, or nil.
I see. Yeah. Okay.
And that's not terribly helpful unless I have some B's that are forced to be not nil, because A as a free type variable totally takes nil as one of its types.
I see. Okay.
So I did this like a year ago. I ran this poll that asked, how do you do type annotations? What was people's favorites? Where the poll was like square brackets for types and angle brackets. Like Java does angle brackets for generics, and a bunch of languages did something else for square brackets, and some people did spaces, and some people did rounds. And I had a list of names and did a poll, and a guy came back with a bunch of, some easy things. I hate the angle brackets that Java uses. I'm not certain I like square brackets. Spaces become ambiguous because what
why a question marks doesn't make sense here.
It does, but as soon as I have a more complicated thing, it starts to become more ambiguous.
It makes the type optional, and here the linked list a question makes the reference can be null.
Yeah, Aaron's pointing out in the chat the issue. Where did the question mark go to?
Mm-hmm.
And it's the other one here. Aaron pointed out, you say option and angles everywhere, whereas a lonely question mark doesn't group, whereas the angle brackets group. So then it becomes more difficult to say. And Aaron filled it by putting in curly braces to do the grouping in his second example.
Yeah. Because if you put
if I want to have an optional int, 0 is null. So to have an optional int, yeah, I have to have an optional struct containing an int.
Yes, you have to wrap
an option of an option of an int.
Yes.
I have to have a struct containing a struct containing an int.
Yeah, if you want an optional int, you must wrap it now. It must be wrapped. Which right now, the way I'm defining it, wrapping is a thing that you buy into, and you don't happen for free. You get the null check for free on all things, including ints. But if you want an optional int, you have to wrap it. Okay.
So with a linked list, could you assign a value? Okay, so the weird thing to me is it looks like you can assign a value to value, but wouldn't that be confusing if you were trying to assign a value to next, because next is also letting you assign a type?
Well, I could claim that this is the type for linked list where values finally assigned a type A.
The uppercase, as we discussed in the previous CCC, is actually an H list. You can call the new linked list with a different type, which each new instance of the linked list can you put a new different type, correct?
In the first one you can, in the second one you cannot.
Yeah, and you track the type.
I track the type, and it's polymorphic, and it does the things you expect it to do, and demands the list of string as a list of string, and so on and so forth.
So I would actually rename the first H list.
Yeah. The first one, I use the same names here so you could see them lined up, but the first one's the generic list of anythings.
Because if you can construct H list, that opens the.
What are you saying? You're saying H list?
H list, yeah, heterogeneous list.
Oh, heterogeneous list. Ugh. Okay, mixed list. I don't know. Generic list.
That's the shapeless Scala library calls this.
I see. In the land of Java, you just say list with no generics added on, and that's what you got. You got a list of object in Java. That's what the first guy is. The list of object.
Yeah. So you track the whole list, all of the types of the list. You track it as the one whole type, and you know actually each instance of the linked list which type contains.
No. If I have a list of objects in AA, same as Java, they are untyped. The compiler only knows they're an object, doesn't know what it is.
So
You have to have an is a test. Whereas a linked list of A's, where the A happens to be a string or an int or whatever,
actually,
then I know.
Value is equals object in this case.
Yes. Yes.
Can you
I
try?
can't. No, I can do tuples. Tuples are a list where
So-
every field is typed specifically.
Mhm.
This linked list is specifically same as a Java or a C list. There is no typing on the value. The first one, no typing on the value. The second one, the value can be whatever it is, but they're all the same.
I think my question is, for A, could you write a type? Could you write a value, could you write a type anywhere you're allowed to write a value?
You can put type annotations in everywhere you want, and that would you're maybe saying this.
Okay. Okay, when you had the value equal A, I was just wondering what happens if you put it if and in capital A with assuming A is a type.
So we're in a type expression here. I can only do type things for syntax. I can't put an if.
Yeah, but what I'm confused about is when you do value equals, can you only take in types or can you take in values as well?
Okay, right. Okay. So I'm hoping I'm coming up to that in a minute.
Okay.
Because inside type declarations, I have a place where I flip to, that was what I was talking about, my syntax change that I mentioned earlier. Well, it's fine, I'll just do it here. As soon as I go put an equal sign in, I really want to say, now I'm in the value space and I'm gonna put a value.
Okay, yeah, because I had some syntax problems related to this, and I had to like make a way to tell the difference between types and values.
Okay, yeah,
And
I
that's
have
why I
a
was
way to
confused.
tell. I can flip between types and values, and you can have final assignments of values as part of the type declaration, and that happens in the next slide over.
Okay.
So let's go look at the next slide here. So here I have a .2 is defined to be assigned a type. That's the colon equals, the colon there, equals colon. It has some structures. And right now I'm doing this syntax, and I probably need to do this syntax, but we'll come around to that in a second. Here I say dist as a type name equals, now I'm going to switch to the value space and write a function. So the function is an anonymous function. It's in a scope of .2, so the dot's well defined to be the this, so X and Y are the fields that are defined, but that's a value. It's finally assigned into the dist field. So .2 has a field called dist, which is finally assigned a function. And therefore I can come down here and say .2 dot dist. I just look up dist in .2 as a field. Oh, that's typed as a function. It's a value as a function. I got a function out. I can call the function. So I put a pair of parens to call the function, and I just called dist out of .2. But semantically, I did a field lookup. .2.dist is a field lookup. That is a field lookup. That is not a method call. That is a field lookup. It returns a function, which I can then call.
And in theory, there's one copy of .dist on every instance of .2, but the implementation can do what it wants.
Yes, and the guaranteed performance model here is final assigned things in the type declaration get moved into a prototype that is shared across all instances. So I don't have to have a function for dist. I can have a magic other thing. Except my coloring is wrong here, because whatever character font effects, maybe yes, no, automatic. How about automatic? Yeah. And so now I can declare a global variable pi that's a member of math or a member of .2, and I could say .2.pi and I get pi back. That's a finally assigned value. It moved into the prototype.
That would equal. That would
And
mean
Matt
static.
says he likes
Yeah.
colon type always better, which I do too. I've had more time.
In Java, that would equal static for the pi.
Yeah, it's same static. So the final assignment there means it's final and it's therefore static because it's the same for everybody. I don't have mutable static fields. If you want a mutable static field, you put it somewhere else and put your class declaration nearby. And it's another global variable, basically admitting that Java statics are just global variables.
I like the colon definition instead of the equals. It makes the distinction between types and value more
Yeah, I
severe.
do too. So and Matt's saying he does too. So I think that's the easy way.
That's the easy way.
Yeah. The one thing that I don't have here is well, I guess I do. No, I do. Okay, fine.
The question is, can you support a record? Field equals some value, and that would mean a record, not a class, not a definition, not a type.
Well, records are structs in my head. What do you mean by so when I add a field here?
So no, it's you define them inline without defining them. It would mean somewhere in the code you
Anonymous structs?
Yeah, that's like an anonymous source, but you name the field something
like this endpoint. This is an anonymous struct where I've named the fields.
Yeah. Yeah, that would count as a record, I believe.
Okay, yeah, that's I don't know what Scala record is, but
no, it's not Scala. The records are values themselves. They're not. You do not create an instance of themselves. It's a named instance with it's a value with named fields.
Yeah, this is a value with named fields. And I assigned the value into endpoint, and so really the ampersand open here just said new allocate private static internal hidden class with a single instance.
And you mutate later. Yeah, that counts as a record. Yeah.
Okay, that's what it is. Okay, subclassing, which I'm work in progress on. But the prototypes lookup thing for the name lookup, the parser does the name lookup. He inserts a search up a superclass chain lookup, which has to evaluate at some point. Which in this case means he'll do a field lookup in the prototype, but the prototype for 0.2 and 0.3 would be different. So I want to override the dist. So I'm going to get dynamic dispatch, but this is x squared plus y squared plus z squared, and it's different than the prior dist. So this becomes in this case here, 0.2.dist, the compiler will totally say there's only one 0.2 type. The dist is a static field. I will hard guarantee you got the function called a dist without dynamic dispatch. Here, I'm going to do the field lookup. The field lookup looks at either in a 0.2 object or a 0.3 object because I don't know what I'm looking at. So I might get a different value, a different function when I did the field lookup, and then I'll call it. So it's dynamic dispatch.
You said it, a prototype that will be shared by instance. What do you mean by that? Yeah, a pointer with you carry along a pointer to some shared.
Yeah, so the pointers. So point as here I make point defined as a 0.3, but assume that it could be question mark, some random, it's either 0.2s or 0.3s, I don't know. It's shapes or it's pets with cats and dogs, whatever. I don't know what it is. Yeah. But it has some common shared subclassing. Yeah. Dist is in the shared subclassing. So when I look at the 0.3 object, I'll go to the virtual table, which comes off the header. So the implementation says I have a header. I got a V table in one load. From the header, from the V table went to the dist offset, and I loaded. It better be a function of no arguments other than the dist pointer, and I call it. But I don't know which function I loaded. I loaded either a 0.2 or 0.3.
You said specifically a prototype. That was my question.
Yeah, prototype. Good class, prototype, whatever you want to call it.
Okay.
There is some shared common thing that happens here. You get an instance for the mutable fields. You get a prototype or a class for the immutable fields. You're declaring the immutable fields inline the struct, same as you would in C++ or Java, but they're going to get moved off to the prototype object just as they do in C++ or Java. So it's like identically implementation wise. The only difference is, one's a static call, one's a virtual call, and I may give a cost knock on the virtual call that you can ask for a typing that says don't make any virtual calls.
Because the definition doesn't depend on the actual instance of point two. In this case, it does, but in the previous example, it doesn't. So we can isolate. It doesn't need a this pointer. It doesn't need something define it inside the point two.
I'm sorry.
Correct?
Say what now? In the previous in this example.
No, in the previous example, that make the dist static. You can isolate it.
How far back do I got to go for that?
Oh yeah. That's.
I did methods. Methods were just functions. No, I don't know. All right.
That we were talking about 10 minutes behind, but something you can isolate the dist from the point to make it static.
Yeah. So just plain old dist. Here's dist as a that's just a local variable defined in scope.
Okay.
And and I can make a point version of it. Here is a local variable defined in scope. It happens to take a point too. Here's a version of dist, which takes a this pointer, which is a point two. And X and Y are in scope. So he can just look up X and Y without saying this dot X.
Yeah. We will talk about it. In this case, the dist is tied to the implementation of point two because it's dependent on its field.
It turns out that in all my functions, every last one of them, there's a hidden first argument. It's the this pointer for point two. It's the stack frame. It's the stack frame on this guy. All things above are in scope, including the point two variable are in scope. But he has a second argument that's real. That's a standard C argument. But he has a hidden internal argument, which is the scope structure. So semantically, all stack frames are scopes. It's a scope structure. You get it. You get the enclosing scope as a hidden first argument.
Yeah.
Okay.
And that's a closure. If I were to return point.dist to something else and then call dist, it would still give me the dist on the point that it came from.
Yes.
There is no separating the functions from the objects that they were born with. Those just are closures.
That's correct. So basically,
that solves like half of the security vulnerabilities in JavaScript right there.
Basically, there you go. Basically, I use fat function pointers. You get a this argument, and you get which function you're going to call into this argument. But that has to be found.
That's wonderful. JavaScript had so much pain with the this pointer being rebound dynamically.
Yeah, I saw those. It's like, holy fuck. Why are you doing this to yourselves? Fine. And in Java, you can say, I want the method out of a function and without a this bound yet, but you have a not yet bound function. And you then bind it later. But you have to use reflection to get that. And I was just like, nah. So I skipped that part. All right, you're going to say something, Theodore? Or?
No. All good.
All good. Subclassing. We all good here?
Yep.
Going to claim this was 0.3 versus 0.2. And I'm not sure I like my less than or equal to as a inclusion, but it is a test, but we can argue. Dead code always types. So in the first example, because true is defined to be not null, it's always true. Therefore, I'm going to evaluate 3 and 4. Therefore, calling the AND operator on a string while it's badly typed doesn't matter. I ignore it and throw it away. So dead code always types. So if I want to get a file descriptor, if I'm a Linux, then I'm going to do some Linux call and a Mac and Windows and yada, yada, and some default case. And in all the cases that I'm not on the wrong OS for, they're all dead and I don't care and they don't type. And so I don't care. They have syntax errors. Like the Mac OS call is just not valid syntax on the Windows call. And so it's a syntax error, except it's dead on the Windows. So I don't care. And the typer will say this is well typed.
That's also great for junk you didn't import.
Yes.
I have
Yes.
mixed feelings about on the one side I get it. It's the exact is the equal functionality of the if define, because if define just skips all the code.
Yeah.
But on the other hand, you can get a code that is stale, and you have to when it does some pass
When
the
you
check.
change when you fix the other code that let it not be dead, you now have to fix that code.
Now,
Yeah.
that's
that's
my point. If you get the whole, you can get a lot of fixes. A code that needs a lot of fixes.
I'm
because
just saying that's standard C code. It happens.
Your trick, yeah.
C++, that's entirely how it works.
Yeah, I get
Yeah,
that.
the way I see it, there's two cases. Either you have a bunch of tests that call that code to make sure that it didn't get stale, in which case it's not dead in test mode because you are compiling the code when you're in test.
That's a nice.
Or
you can
have
make
no
test.
tests that make assertions about that code, in which case it's going to get stale.
Yeah,
even
that's
if it types.
that's a nice statement. You can have a test that it passes, and it's now you're forced to type check it. You can make a
If
test
the
that
compiler
argument.
can prove the code is dead in production, but you still also want to test it, then yeah, then the same code has to be run through a test which is saying it's turned on in test, and then it will have to be typed at that time.
I believe that was the Aaron's point, which is excellent.
If I have a binary build that doesn't import a bunch of code, and I have a test build that imports a lot more code because it's got all the test harnesses and stuff in it.
Yeah.
Like when I do my test build, it will touch all this stuff. So
yeah, it's going to be superset. You'll have to type it in the test code, but you'll know that it's not being typed in production. Therefore, it's dead in production. And why are you testing it? It's dead code. You're busy testing dead code. Okay, you are, but acknowledge that. That's what you're getting forced into. Hey, I'm busy testing dead code. Maybe it's important because it's going to be not dead after a while, but you're not passing your test either. Fine.
So you can make a
That was one of the classic problems at Google, is that daylight savings time was always poorly tested.
Yes.
Because, you're making a release every 2 weeks and you're like, it's 6 months till daylight savings time. We'll come back and fix this.
Well, Land of Hotspot has a million billion, complicated slow paths. The fast path was slick and easy and well tested. The slow path had to check the debug info layout, had to check what was live or dead in the garbage collector layout, only if a GC cycle hit then, and yada yada, infinite number of these things. So there was a lot of long tail bugs on code that was not going to get tested very often. Yeah. And we had to fix that with engineering on how to test those things. All right, that's it. Everything else I think is just what we're doing here. State of implementation. Lots of tests have passed in the past. We're not passing right now, but probably will pass again. Combination of Hindley-Milner and flow typing. I can do all kinds of fun typing games. Strong extension of both of them to get something that's strictly stronger than either, theoretically stronger than either. So it's not system F, but it does something different. I have some asymptotic speedups as well involving memoization of Hindley-Milner. I have a cost model in my head that's not really implemented that says everything is known what a cost is, and you know what a function call is. So parens have to be involved to make a function call. There's the adjacency one will be a function call either, but that's also obvious from just looking at it. I'll probably have cost model keywords. Those are coming, not happened yet. Hand in hand with that is you're going to do GC or not, and zones or not, or whatever's going to be. Security keywords, FFI keywords, exception keywords, things like that. I'll probably have no exceptions throwable across a module boundary. You are forced to catch all exceptions and have the module boundary return a pass, fail, true, false, an okay, and a result, or an error and something. And people who call a module boundary know that they have to deal with that module failed, and they'll have to deal with it at that time. Lifetime things. I think my typing system will let me get some sort of linear typing fairly straightforwardly. And that'll turn into something useful. Tag unions are probably going to come. I can do something with tagging of ints already, but I probably got to tag unions directly. Don't know everything I want to do about exceptions. Everything else here is just me having open discussions about what's going on. So I guess I can skip this or go down and whatever people want to do. There's a lot of open questions here. Tagged units are probably going to come. I mentioned that. No exception across module boundaries. Yeah, that's one of them. Don't know what I'm going to do with concurrency directly. Bunch of folks, there's new stuff's gone around the last couple of years I'm going to look at. Including ownership rules that play well with Rust, maybe, for when you get concurrent or when you don't. And the X to C model is basically it's an actor model, which may also play into what I want to think about how to do stuff here. I'll probably will live with something pretty close to the Java memory model because it's well spec'd and well verified. Except I'm doing something a little different with final fields versus final writes. And that's just a flow test thing.
What are the chances you can say exactly the Java memory model, or do you think you're going to need to do something different?
I will do a subset probably, because Java memory model has special things about strings and string mutations and shit that has some weird corner cases that don't really apply here. And otherwise,
Cool.
you know, volatile as a type on a field means do something in ordering and do something ordering around locks. Probably at least one low level flavor of memory, of locking or concurrency, so that you can build up higher levels of concurrency algorithms. Like Erlang says right away, I have actors and message passing. That immediately denied a certain class of interesting concurrencies. You know,
that's one of the things Clojure did very well, is they wrapped cas in a bunch of primitives that were just like, hey, this thing's an atom. You can only modify an atom by calling update and passing in an atom and a function, and it will try to do something sane.
What that did was it denied the ability to write an efficient non-blocking hash map. I cannot, in that model, write an efficient non-blocking hash map. I must have some extra layers of indirection. So Java util concurrency.
Yeah, your non-blocking hash map, you're going to end up calling cas directly.
Exactly. And non-blocking hash map is, in my head, a very powerful common use case where people have large shared concurrent caches under heavy load. Every memcached on the planet, and there are a lot of memcached, effectively are doing cases into a shared concurrent structure. And you want those to be efficient. And so therefore you want a guarantee of no indirections until you reach your cas, because they are on the hot path for everyone's lookup for everything. So I want to be able to write a non-blocking hash map.
How about a future?
Yeah, and then there's futures which have a cas that you would get a bit that says it's done or it's not. And if it's not done, I take some locks and I start computing things, or I erase to compute. But if the cas bit said the thing's available, I want to read the future straight out. So I want a cas there on a future. The cas is probably baked into the future object as a convenience, but I don't want the language to say, after I built the future object manually in user code, I then took another layer of indirection to get to the cas that I must have in order to successfully get the value out.
But they occasionally they have to live on the heap, their heap located objects. How would play
well,
that?
You got a cas, you better have a piece of memory. It can't be in a register. So
okay, that's how they would play with the cost model.
They got allocated.
If you annotate something that is a future operation, then automatically you are on the heap. So.
Yeah, you made a struct which is defined on the heap. You did a new.
I told you it's volatile. I bought some cost.
Some memory. Yeah, you said volatile. There may be some memory there. So it's already, you know, a field in a struct. Well, the struct got on the heap. I didn't explode the struct in line. If I explode the struct in line, it's compiler optimization to make your life better. But I'm not giving you a hard guarantee that a struct got exploded into registers, and at the same time, it had some sort of concurrency locking shared memory thing, because if it's in registers, there's no memory and it's not shared, and I don't know what it means.
But you can do something clever if you're like, oh, I'm looking at this code, you generate your volatile thing, but you never pass it to another thread, and you never make a second pointer to it. It's always got a single unique pointer. Like
now that one, that case There's two versions. There's the one where best effort compiler optimization, and the version where the typing system, you get to declare, oh, in register this struct. The typer will guarantee that he knows it never escapes scope, it never get anywhere else. I escape analysis it to death, and I can guarantee know that it can be in registered. Maybe I put it on the heap because stack or whatever, because I ran out of registers. I spilled it anyhow, I went to the stack, fine. But I can guarantee you that it did not require a heap. And you said volatile, that is meaningless. So I probably should throw an error at you saying, you used volatile on a struct that you also declared was inline in registers or didn't escape or whatever. You used volatile on a struct that you also declared didn't escape. That's a type error.
Yeah, I can totally imagine the workflow of a performance person who's just dropping no escape on everything just to see which things do escape and don't escape.
Yeah, right. No, totally. Yeah, right. Start shrinking the bounds of this shit in the type annotations until the compiler blows at you, and then you can stop and say, why did it? Oh, it took the exception path. Oh, the exception path did something stupid. Hey, if I nil this thing out, then it doesn't get escape on the exception path. I can drop it again. Yeah.
Or the opposite. I add a dot clone on the exception path and explicitly say I'm making a copy right here, and now the rest of it is no escape.
And the rest of it remains inregistrable. Yeah. Totally. Allocate on demand on the rear path. Yes. That is a thing to be done. I have all kinds of other open typing questions. I already do the nillable, not nillable thing, but I want to be user extensible. I want to have what people call session types. I think I can do that. I think that's pretty straightforward. Things like this will block, this won't block in this region. I'm writing reactive coding. This might block. I want to put ranks on locks maybe, so I can guarantee no deadlock at compile time. I can obviously do physical unit math, or I have in the past been able to do physical unit math.
I assume you're not asking the user to annotate things with rank order for the locks.
No, but he wants to declare these locks shall be rank ordered with all other locks that are declared shall be rank ordered. And then the compiler infers, or he tells you, I can't figure out a path. I have two paths here that look like I can go either way. The error message from the compiler has to be good, but I think I can infer the ranks.
So I declare somewhere these 17 locks are rank ordered.
Yes.
And if the compiler can't rank order those 17 locks, then no
you get an error, and maybe you also get, hopefully you get a reasonable discussion from the compiler about why he can't rank order them. The rank ordering in Hotspot, we had roughly 50 odd locks, and manually rank ordered, statically. They were tested dynamically. If you ever took a lock when you had an out of rank lock, it stopped before you actually acquired the lock in the debugger. And getting the bugs out of that took a long time. There were some weird path corner cases where you did lazy class loading on demand at blah, 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 and a GC cycle and this and that. And I was unloading a class and loading, and the JIT was in there. And suddenly you got a rank lock error. Bounding data races. Make sure that goes in the doc. Yeah, you've done that one before. I read it briefly and I wasn't ready to deal. So I will definitely be coming around on that at some point. Modules, I'm sort of, Aaron and I have gone back and forth on this a few times. We're kind of in a feeling that a module just be declared as a struct that'll be given for sort of out of scope to you. And then you just name the variable you put the module in, dot the fields of the struct, and that's how you get at it. And I can build that in reverse for you, how you export a module pieces.
Yeah. Here's the thing, it was top-down evaluated.
Yeah.
It imported stuff, those got top-down evaluated.
Yeah, and the issue.
The only thing I think that's tricky there is cyclic imports.
Yes. I didn't think about that.
Where you're in the middle of importing something and you're like, give me the struct. And it's like, this struct is null because you're in the middle of building that right now.
Yeah, in the land of the parser with forward references, I can deal when I have them all syntactically available. If I am executing code to do an import, then I don't have them syntactically available. And then then you have a circularity problem. Yeah. I get that all the time in Java class initializers. I get the damn circularity bug where I get a null funny and I have to sort on it for a while. The other one is if you list modules not as an executable thing, but as a top level declaration, then all the tools that do module level composability play in. And in the land of like Python or JavaScript, where there were 3 module systems, they went to a syntactic uniform approach that was both executable, but everyone wrote it the same way. Therefore, the tools could look at this pattern and say, oh, you're importing this module, except for the dudes that did lazy late dynamic imports, and they just had to suck it up.
That sounds fair.
Yeah. Yes. I mean, yeah, no. And but it made
To
life
say
more
things
complicated.
like, I will crawl you and make the full dependency tree as long as you have all of your imports before anything that's not an import. And the minute I get to a line that's not an import,
Right.
maybe fetch didn't pull everything from the internet in one
class
shot.
were named. It wasn't a string. I didn't know what you class were named. I quit there. Later on, you said, oh, and this one, although you don't look like an import, it actually is import. This is Java annotations. There's some annotations. This is actually not dead. We just class renamed it instead of just loading it directly. Okay. Fine. Currying syntax, I probably won't do this one because it's easy to write a 1-line function that's just the curried version of another function. Default arguments, again, probably won't do it because you can just do overloads with default arguments. It's pretty straightforward. Var args, I probably will do. The syntax is a little TBD.
Particularly if you allow explode.
Yes.
If I have something that takes 10 arguments and I give you the first argument and then
Yes.
dot, 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 break this vector, and then the 7th argument, and then dot, 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 break this vector.
Yes. And then under the hood, I treat it as a tuple that I'm passing along because you're going to hand it to the next body and the next and the next, and somebody explodes it. That probably can be it there. That one makes more sense.
I think you can sort of hide var args in your tuple expansion.
Yes, that's syntax. The goal there is to hide var args in the tuple expansion game. Yeah. I like pattern matching. I love the coding style that comes out of that. So that's going to happen. I don't know what the syntax looks like. Eval is going to be a thing, which, you know, free eval and backtick encodings and shit like that. But I have some security issues on eval that'll probably be defined to be the normal eval has nothing in scope. You pass me a string, it starts in an empty universe. You want to pass something else, it's easy enough for you to thunk your own code and pass that into the eval to hand it something that so it gets some context to work on, but then you control what you're exposing. But you don't get a by default eval that just reads the current lexical scope and hands it to you.
The other thing that's nice is if you implement your sort of backticking stuff in a separate library that's essentially a string processing library, now it becomes much easier to write tools that read, transform, and write out the AA code.
Yeah. Yes, because there's a library that's already doing something there. Yeah.
Right. So you can sit there and be like, here's my parser. My parser can do things like recognize that there's holes here because you use backticks, and then you just string format them in. And
yes,
blah,
and the string
blah, blah.
formatter said you used a variable name, therefore you actually wanted the value of the current variable instead of the name, or there was a way to do it or something. Yeah. Ecstasy had a cool one I liked, which was once you're in the formatted land zone, so I'll use backticks for this, but he can have x equals, and that's look for the variable x in the current scope, print x equals, but then print the value for x inline directly as a shortcut to pretty print x. You know, but also so you can see $x. Hey, you know, x equals $x kind of thing, stuff like that. So there's some sort of backticking coding out there for making a string.
There's asymmetries that are mildly annoying. I was doing something in Rust and I was like, oh, I need to make a vector of bytes. Great, there's this byte literal syntax, or it could be like b quote whatever.
Oh yeah.
Oh, I need to display some bytes. How do I print it out as the byte quote syntax? Oh, they didn't give me any code to turn bytes back into byte literals. What?
Oh, interesting. All right. Well, you can wail on me when I get there and make sure I do it right.
So it's just really nice to have a lot of the sort of parsing library and logic and working with code stuff just in the standard library.
Yes. Overflow safe integers, I will surely demand that you name a special type that comes out of the standard library somewhere. That's, hey, I'm doing overflow checking and wrapping, because these get expensive fast. And if you want to be expensive, you have to ask for it. Private public, I'll probably do something with leading underscore as private, not leading underscore on the name as public, but I don't know. String variants, I'll probably limit to a handful of well understood performance model strings. And then everything else comes out of a standard library as I'm a Unicode 64 string, and you just sucked it up and you asked for it specifically.
I vaguely remember people having trouble with Go and capitalize being public versus private.
Okay.
Something about serializing data or trying to deserialize it, and it wasn't matching up.
Okay. Well, I can be talked out of this as a bad plan, the underscore or not, or it might be a good plan, it might be a bad plan. I don't know.
I guess my question is, what is public private buying you that closures don't already give you?
Well, it buys me the programmer weirdness budget. I have to privatize it by making it in a closure. Under the hood, I'll take your privates and make a fucking closure. Okay. But I don't want you to have to think in closure style to get private.
Okay.
That's literally the only reason at the moment. Yeah.
Because one of the things I've seen in Rust maybe was underscore means I may not use this.
Oh,
and then you get warnings from the
suppress
compiler that's
unused-
like, hey, you're doing work to build this thing, but it's dead. Like,
right, suppress the.
but if I say underscore name, then it's like, oh, this thing's allowed to be dead. It's fine. I'm deliberately ignoring it.
Okay. Yeah, I don't know. I have lots of times when I'm middle of hacking where big chunks of code go dead because I comment them out. Big chunks of variables go dead. I do not want errors coming out on the dead variable because I'm going to return that code back on the next go round.
Yeah.
One of the ones, my most favorite one to hate on is IntelliJ optimizing my imports. So I have com.cliffc.aa.aa.unimplemented. And I throw unimplementeds all over the place and things on the middle of them. I cleaned all the implements out of this file. He gets rid of the import for it. Sometime later, I come along, I add a new hack and a new unimplemented. He gives me a type error. And then he says, then after I fail to compile, I will then automatically import. So the next compile will work. And I'm like, compile, failed for unimplemented, compile again. Oh, it worked. Fuck you. What are you doing? And if I'm doing it in, Emacs, I just don't optimize the import away. And I just let it sit there as an extra import. And no one fucking cares. Fine. Never mind.
I still want my editor to gray out things the compiler knows is dead.
Yes, but that's fine. They're just not whining or failing to compile. Fine. Never mind. All this. All right, done. There you go. See, it was an easy 10-minute talk, except it went to 2 hours because these things always do. Okay.
We're a kind of question-y group.
Yes, well, that's the point. And you make me rethink my design goals. Or my costs or whatever, like syntax gets rethunk. A equals just colon, pretty solidly colon here. And equals is I'm assigning, and I switch to the value space, and I'm going to go do that in the value space instead of in the type space. And fat pointers, I threw it out there. Fat function pointers, threw it out there. No one blinked an eye. So that's fine. That was one of my. Is that okay? Yeah, I think that's actually okay. I don't know. I have some funny things in here. So I don't know yet. Oh, let me go do this one here. I'll show you guys this guy.
Yeah, the one I'm going to have to think about is the double pop return.
Oh, yeah, the double up return is still a big open question here.
I've used returns to break out of for loops plenty. The fact that return and break are not the same word.
Okay, let me do this.
I use that.
Yes, return and break aren't the same word. Share again. Okay, here you go. You see my browser tab. Okay, there it is. Right in the middle. Type angles. All the Java people said yes. I hate them, so I'm not going to do them despite all the Java people.
No, no Java, no.
No. Okay, squares for Scala and Python. Space. Elm, Haskell. Somebody did rounds, and they told me later and I failed to update the question. But I know there's people who do rounds.
You should.
The nice thing about rounds is it's just, well, your type is a function over a type.
Yeah, I could do curlies too, and I could do a function syntax and for type variables, and that
I have a list. What happens if list is a
list of-
parameterized thing. Oh, well,
Yeah,
it's
yes.
a list of T. Well, it takes
You-
T and gives you back a list of T. Like,
Yeah, you have to
Cliff-
do, right, you have to nest your parameterizing, and the functional type parameter syntax gives the proper nesting behavior on those.
Yeah.
Yeah.
Make
my
the
general
poll
rule of
again.
thumb is if you put the braces parentheses there, you should be able to read it as the first word of and then the thing in the middle. And if that sounds wrong, parentheses were probably wrong.
Oh, type of round.
Yeah, it is a list of T. Okay, yeah, maybe
Oh,
it is
list
a
of
function
round.
call.
Yes, yes. List of square, list of circles, list of shapes. Yeah,
Make the poll again.
make what?
The poll again.
Oh, run the poll again?
Yeah.
You'll
Yeah,
you'll
the
you'll
second
go
version.
drum up more Scala folks to pile in? I
Maybe.
could.
I don't know that much Scala folks, but I will vote again.
Okay.
So no,
know.
just to reiterate and see what happens.
Yeah,
So,
This is getting science for Alan's sake here. He gets actual, actual numbers.
I agree that the angle brackets have the lowest weirdness budget because of C++ and Rust, but I don't like them.
Don't like them.
So I don't want to do that.
I don't like them. I won't use them. So
I don't like them, Sam. I am. I don't like them.
I don't know how much effort it is to do that if you're because if you can tokenize the greater than as a shift operator, so closing
I
it
don't
seems like
tokenize.
a pain.
See, I don't tokenize,
Yeah.
so that problem solved.
In my head, a parameterized type, we have syntax for passing parameters to things. It's a parameterized type.
Yeah, parameterized type. Yeah, right. And you can do the syntax for typing. And then for Levo's sake, no, I have a hand roll recursive descent. There's no lexer.
Okay.
In particular, if I'm doing operator overloading, the operator overloading path is interesting, and that I find that less than, and he passes the is op. Now I'm in the operator overload, which has a bunch of other rules on it. Land before, and he'll find the second open and say, hey, but he's only doing that if he's in the operator namespace. So you're in the value space, parsing the value space. If you're in the type space, there ain't no operators. So I don't do the operator question.
So I think they do a $sign for because a lot of parameters are just one variable,
Yeah.
like a vector.
Yes,
I think they just do a $sign, and if you need more than one, you can use a $sign rounded parentheses. So I kind of like that.
You've picked a character $sign. That's the type variable. If you need two, you go $0, $1, or $A, $B, or something.
I think what D did was they just had rounded, so you can choose because it's ambiguous if you have more than one. If you have a type inside of a type, you don't know if the $sign is on the inner or outer.
Yeah, right. Yeah. That's the problem that's what the functional syntax works on, solves for.
just use the squares. Don't mess with the type variables, please.
Well,
I guess my question is, what does the square communicate that the parentheses don't? Is it just to make types look more distinctive, or?
Yeah, more distinctive for me.
Yeah.
I am vaguely in favor of squares over rounds, but I'm definitely not decided, because that one's still kind of like twitchy either way. Angles are just like,
What about $$ for single parameters?
what am I doing? Oh, it's going back to the docs. Do we have any extra? Yeah, you put in there, right? So now put the list int is equal to : list of square bracket int, right?
You can share.
Yeah. It's list of angle int what int in list of int here's all the variations thereof. But we need a reasonable 2-argument thing, like a map of a function from A to a B. What's going to do this is another version. I don't claim that's any good either. Throwing out things here. So map is,
So for the last one, I really want it to be named. If you are not naming the types that you are parameterizing over, I don't want to use braces. Because in the rest of AA, brace indicates a namespace.
It does. That's the right. I don't claim I like this.
So like that one definitely needs to be
You claim no.
I.
Wow, I don't like that.
So like if you have a map, you might want to be like,
Yeah, I'm about to say, I was trying to do a map here. So I've written a map syntax, which is with angles, which is typed as failed the type syntax. So let me try again, which is typed to be a function, which takes an array, a collection. So a square bracket, that's a collection. Collection of array, a collection of A's, and a function from A to B, and a collection of B's. And returns a collection of B's, sorry. So it changes a collection of A's into a collection of B's for the map. Now, square brackets for a collection, there's a couple ways I could do the collection syntax, including the A in the middle for the type, and that's not defined yet. So here's the A in the middle. Whoops. Oh, Google, what did you do? I don't know that this is better. Right. So I think too many people, weirdness budget, too many people like this section. So we'll leave that for the moment. Now I have angle brackets, right? So if I do just spacing, I get this, which starts to drone on as you add type variables. And if themselves A or B is itself a type with more type variables internally, like I'm going to take my A's and it's going to turn into a list of A itself is a list of a list. And it's going to go to a B's. Now, whatever the type variable in A's, you know, what's so if I did angle brackets like this, oops, comma and B. So here's the syntax with angle brackets all the way. Right. And actually here I can now do this.
what is C?
Well, A is a collection of parameterized persons by, I don't know, by race. And B is dogs by race or whatever.
Sure.
Right. So it's some stupid thing. Now I've got too many angle brackets and the C's are shared. Or they're not shared. Are those two C's the same type or are they not?
Nope.
Oh yeah, right. So you're like, oh wait, what the fuck? Now what do you do? Well,
So
I can say that they're the
this-
same so that they're because I gave them the same name, they are the same thing. If I wanted them different, I would have to put a D instead of a C there on the B guy.
Yeah.
And then I have some C's and D's in my output type. That's fine. But that really means that C became a free variable at the time I started up map. And all I'm doing with the angles is I'm breaking out, like if I remove all the angles and go to the space version, so let's take this, leave that guy there. Let's go add the space version here. And there's all kind of ambiguity shows up here. Right, I don't need a comma. I get this. Oh, what the fuck? Is a map a 5 type variable thing? Is C a type variable taking B? It's completely ambiguous. So I think you can't do spaces as soon as it's complicated.
Without an extra symbol,
Right.
you
Even
cannot.
if I was doing spaces, I would require something that was parameterized over two things to take a tuple.
Okay. Yes. And now
In the same way that your functions are technically one argument functions, but no one cares because tuple unpacking is making them not.
Right. So I could put a comma there, and that says that map is an initial. He has 2 type arguments, but as soon as A takes 2 or B takes 2, the comma doesn't work. And again, still ambiguous. So
You need a symbol.
No, I think you want some kind of parentheses there.
You need an extra symbol to scope the type application.
Yeah, right.
That's unavoidable. With a more than one type variable.
With more than one type, you need something, right? And now I'm like fooling around or fiddling around with what does it mean to have a type syntax like that. So here's a version. I'm going to hack on this one here. Where
so if your parameterized
function,
type syntax is just a type that takes types as parameters and returns a type as a result.
So here I have, something this guy takes an A and a B and a C as a type function, and he does the map. And now I can do things. Is that the right place to put that? I did double curlies as a type function. And his output type is map of, no, it's not yet even, it's not even there yet. So I don't know yet.
The below syntax is akin to type lambda. You want a type that parameterizes another type.
Yeah, like this guy is
the type
defining,
itself.
or C arrow, and then he's an A of C and a B of C. And he does gosh, I don't know. I'm still not getting the right syntax here. Where do you put the types as a function parameter here? Why am I doing this here? So what does Scala do here? You put squares and your problem goes away.
Yeah.
As soon as I throw squares in, the problem's gone, or rounds, or either way. Yeah. I'm trying to come up with a lambda syntax. Yes, you put squares in, and then you said yes. So you find two free variables. Now I use caps. Oh, what? F is this is your lambda syntax all the way. I mean Scala syntax all the way. He takes two arguments. He takes a collection of A's and a function from A to B. So you have to put a collection in there. And it's typed with a C. Oh God, you're getting big here. I mean, the type I've described is awful. Oh, and C is a type variable that takes another type.
Yeah.
Okay.
It's not. Yeah, that's the C is a higher kind of type. It accepts a type.
Yeah, it's a type that takes a type. Yeah. Map is being higher kinded. It's a type that takes a type.
So, but you can restructure. But you can restructure if but you go lower. If it's a list, you can get rid of the hierarchy.
You can get rid of it. Yes, right.
Yeah, but here you have to be even more restricted because you have to say what the C is. It's because it's a higher kind of type. Okay, but what doesn't tell you much. You can further restrict the type. But that type is a valid type because itself it takes the collection itself.
Well, I don't like the type, and I don't like the type syntax either. But that's not fair because since I don't like the type syntax hardly matters. The type is awful. If the type were not so awful, the other one you just do is actually you do it 2 lines. You do the A of C and the B of C into here. I'll do the 2-line version. That one has a. And he takes a C and he's going to return me a type thing, which is A of C. Oh gosh, how do you do A of C as a type?
No escaping. The C you have to mark. You have to mark the C as a higher kind of that accepts the types. The C accepts the type in itself. So how would you mark that? How would you?
Yeah.
That's that.
Well, I was trying to do A of C as a higher kind of type. So C itself is the higher kind of type.
Yeah.
It takes an A or an X, and it returns me a type, which is an X, angled C. And then I was going to say, I don't know. That's not sensible though.
No.
So I'm with you. There's a thing here.
So either you have to mark somehow the C and X for the.
So a map from A to B is just a type function that takes A and returns B.
I'm talking about a map, but my earlier map was a map that was taking a collection of A's and a function from A to B.
Yeah, it depends. If you make the type map on each collection, then maps just accepts the type the collection is parameterized and takes the B. So the function map in the collection is from what the collection is parameterized on and where it's going.
I was writing a high-level standalone map, not the type of the map in a collection. Certainly, it would be the case that I'm going to have maps as a function in a collection because I can just do that.
Yeah. If you want to abstract the collection itself, then you got what itself a functor. So a functor has there is a slippery slope there. So then a bunch of things are going on
As soon
So
as you said functor, I got my hackles raised up, you know.
yeah, yeah. So if you want to abstract over the collection, you have to have the syntax the higher kind of type. You have to, some syntax for it. So
I have to have
there
a
is
syntax
no
for higher kind of- Okay, I have not yet
Right.
thought about syntax.
But I feel like if I say higher kinded types,
Yep.
that I have lost a large percentage of the developer community.
Yes.
Of
So
course.
And if I say type functions, people know exactly what I mean.
Yeah,
This is
that's-
a function that takes a type and returns a type. It's a type
Of course.
function.
Yeah, in Scala, it's
Like
a
I'm
type
tempted to
line.
never say anything other than there are types and there are type functions.
Yeah,
yeah,
so
right.
Have a
I
nice
think,
day.
I
to
think
type.
that's
It's that
entirely
sensible. Yeah.
fair.
No.
There's a game there where in certain audiences I'll never say the word functor. It just shall not be
Yeah.
done.
If you want to lose half of the line, say the word functor. That's why I
functor
don't
and
use
monad. And you just say neither functor
Yeah,
nor
they
monad.
say that's the key to teaching someone Scala is not to say monad for at least a week.
I'd gonna delay a lot longer.
So
Then
that's
after
why.
they've been doing it for a while, I say, "Oh, we call this particular pattern you're using a monad."
Yeah, that's
First,
fine.
they know it, then you give them a name.
Yeah,
Don't
that's why I used to use dumb words to describe such as concepts, because if you use a complicated words, it's a no-no.
Yeah.
That's what my CS professor in university did. He explained every concept and then gave you a label for it. And then explained a concept and gave you a label for it.
Yeah,
Explained a
that's
concept. He never introduced a term before you knew what it was.
Knew what it was already, and you were looking for a label.
Don't start the lecture with, today we're learning recursion.
Yeah.
Hmm.
Okay.
You start the lecture with, so we've got this function that's trying to do factorial, and we can actually implement the function in terms of itself. Okay. When you have one of these functions that is implemented in terms of itself, we call that recursion.
Yes. Yeah, excellent.
Because the function occurs again. And you're like, oh, yeah, okay, sure.
Yeah, good. That's good. Yeah, fine. All right.
Okay,
Now
we are
I'm
done here.
starving. It's lunchtime. I actually have guests in the house that are doing acupuncture on my ears, so very fun. I mentioned that you guys came
I'm
in
sorry.
later.
I hope you're not describing us as acupuncture for your ears.
No, I have an
That sounds like not a
acupuncturist.
compliment.
Lisa's good college friend from acupuncture schools here. And I have fucked up my shoulder now with my elbow. Elbow is gradually getting better. I'm gonna blame acupuncture for helping my elbow. Yes, good band name though. Functors and monads.
Acupuncture for your ears.
It's weird. And it was working, and it's been working, so I can't say no. Like clearly, like 3 months of no progress from 2 months of no progress from when I fucked my elbow up doing chainsaw work. From the Snowmageddon happened. I fixed my yard by fucking up my elbow doing too much chainsaw at age 60. And nothing worked on it for 2-3 months, acupuncture, and it started healing. So interesting.
Now, I trusted a lot more than if
shoulder.
you'd said you were using acupuncture for the thing with your eye.
No, that was Western medicine all the way. Fucking hurt like hell, and I didn't go blind, so I have to say.
I was gonna say, you seem to still track things.
I lost some visual acuity in my left eye. I definitely did. Beside all the floaters, it's also less able to focus and see. That sucks, but it's better than blind, which was the obvious follow-on. In about 2 days, you're blind permanently in the left eye. Okay. I'll take whatever you're dishing out. Let's not do that one. And they were like, okay, stare into this laser and don't blink. Stuck. Fine. It worked. I can see again. Or something. All right, next time. Till next week.
Okay. Bye, guys.
Oh, are you going to send out the slides you were just working on to the Discord chat room?
Oh, I will totally do that. Yep.
Cool.
All unmodified as well, even though there are obvious modifications to be done. All right.